So, like I was saying, so your 2s cube will give you 2 cube, which is 8, then s cube when you push the power in then plus your ellipses. Okay, so now you come and remove your final set of brackets in each of the terms, and that will obviously give once you are removing the inner bracket, the outer bracket will take the form of the inner bracket. So now your square bracket becomes the ordinary bracket. So that will give us 1. If you multiply this, you get 14s. Multiply this, you get this. Multiply this, you get what we have here. Plus your ellipses. Please take note. Those of you who ignore the plus ellipses here, you know what will happen to you. Okay, so I've told you. Then what do we have? Equal to your next step will be when you take each of the terms here and you multiply it by all the terms here. But when you multiply and you get a term which the power is more than 3, that is, if you get x to the power 4 and above, you have to discard that particular term because it's not of a term interest to you. So now what do we do? 1 times the whole of this will give us what we have here. Okay, then you come and do 2, times the whole of this. So 2 times 2x times 1 will give you 2x. 2x times this will give us 28x squared. 2x times this will give us 168x cubed. 2x times 280x cubed will give us what? S to the power 4 term. You are not interested in that term, so you don't write it. Okay, then now you move on to your minus s squared, multiplying all the terms here. So that will give you minus s squared times 1. That will give you minus s squared. Minus s squared times 14s. That will give us minus 14s cubed. Minus s squared times this will give you s to the power 4 term. So it's not of interest to you. Okay, this one time this will give you s to the power 5 term. It's not of interest to you. So you bring your plus, and those two terms from the s squared expansion and the 1 term from the 2x expansion will now be part of the ellipses that you have here. So in effect, the next step will be your last step, and that's where you have your conclusion drawn. So therefore, whatever that you were given will be equal to, then only one constant term. You add like terms. So if you add the terms in x, you get 16x. If you add the terms in s squared, you get 111s squared. If you add the terms in s cubed, you get 434x cubed, then plus your ellipses. So this also explains the solution to question 2. Okay, and here again, let me quickly go back. Okay, at the point where you are removing your final set of brackets, that's the point that you can write your therefore, draw your conclusion. Okay, take note. Okay, so let's move on to question 3. Okay, question 3. We are asked to expand this in descending powers of x, hence evaluate, so correct to. So as usual, we are going to underline the salient parts because obviously we can see the order of our expansion given and also a certain required approximation. So this requires that descending powers of x, then hence must be underlined. Okay, then it means you have to follow on previous results. Then there is a required approximation correct to 3 significant figures. Okay, so once you have underlined that, we are good to go. So as usual, what do we write? Solution. That's the first thing. Then your question number, you extract, given this is what you are asked to expand first. We'll come and extract this. Okay, so we are going to work on this first. So given what we have here, at the normal circumstance, this is just by the way. Okay, just because you know the coefficient. Okay, I mean, you should know, like I told you, the power here is, I told you 5 and below, you should be able to get the coefficient, in terms of your expansion, your terms. Okay, so here 4, you could have used the Pascal triangle, which would have given us, 4, 6, 4, 1. That is 1, 4, 6, 4, 1. Okay, so take note. Okay, so this will give us, especially if you want to quote the combination 1, you quote the special because the first term is 1. So that will give us 1 plus n combination 1x. Okay, that is if you are using 1 plus 1, 1 plus x. Okay, all to the power n. So let me here, I have space. So if you will use this, to the power n. Okay, you know it will be 1 plus n combination 1 x, then plus n combination 2x squared, okay, plus n combination 3x cubed. So you know that. So I didn't quote it. If you are not matured, okay, quote it, then go and compare and substitute. Okay, I am matured, and I believe because of the examples that the number of examples that we did in class, you should be able to expand this without quoting it. So you quote the question, the theory mentally, and you use. Okay, so that will give us your n is 4 combination 1, your x is now 2x. Okay, so to the power 1, you know your first substitution, it must be, all substitution must be in brackets. Okay, then your powers must be outside the bracket. So that explains what we have here. So at this point, your next step, push the powers in, deal with the combination. Okay, so those of you who could use the Pascal triangle, you will have 4 here, you have 6 here straight away. Then you have 4 here, then you have 1, which you will not write. Okay, so at that point, your next step will be you pushing only the powers in. But those of us who use the combination, the next step will be deal with the combination value using your calculator and also push the powers in. If you do so, you are going to get this particular step. So your next step is where you are going to remove your brackets in each term, which will be all the brackets. So that will be your last step. So you draw your conclusion. So the first part of the question is a direct question, expand. So conclusion must be drawn. So therefore, whatever you are asked to expand will be equal to, okay, if you remove the brackets, this is what we are going to get. Then you come and write, because the question has hence, you know, you come and write hence, okay, whatever that you are asked to evaluate, okay, you state it. This will be equal to, if you want to evaluate this, remember we said we have to know, because we are supposed to use this, we have to know the value of x that we are supposed to, okay, substitute. So what did I say you are supposed to do? You are supposed to come and equate what we have here, that's the 1 plus 2x, to whatever that you have in brackets. So always equate what you have in brackets, then solve for your x. So by so doing, if you solve for your x, that's what. So you do that as a rough work. I've told you, don't let it be part of your main work. Do that as your rough work. Now, if you do that, you know that your x will be, and you solve for x, okay, because you are going to get 2x, move this one to this side, which will be 1.05 minus 1, which will give us 0.05. Then you divide by 2. So that will give us 0.05 divided by 2, which gives us this. So the x that you must substitute to evaluate this will be 0.025. So here you are asked to give the full expansion. So if you go and substitute, it into the full expansion of what you have there. So you carry out your substitution. So when you are substituting, you know, okay, immediately you substitute whatever you are looking for, put it in brackets. So in this case, your powers will be outside. Then your next step, okay, will be equal to your powers that you push the powers in. So if you push the powers in, you are going to get what you have here. Then the next step, you move what your brackets in each of the terms, which will give us what we have here. So now your next step is to combine the whole of this. So get the actual value before you go and approximate. So here the actual value will give us this. Okay, then because we are asked to approximate to 3 significant figures, we cannot end here. Some of you ended here. Okay, take note. That's why I said make it a point to underline the salient part. So if you had underlined the salient part and you ended here, I've told you, go when you want to move from one question to the next question, check and subject your answers through, or your presentation through, what you underline. So if you have underlined and you did that, at this point, you will know that the question required you to correct your final answer to 3 significant figures. So it will give you the opportunity to protect this particular mark or get the mark. So you are looking at 3 significant figures. Your first significant figure will be 1, your second will be 2, so your third, and you look at the next digits, and that is odd. You add 1 to this and replace the rest by 0. But if you replace them by 0, once they are coming, the zeros are coming after a decimal point, you can omit and must omit the 0. So that will give us 1.22. And anytime you approximate, don't forget to indicate your approximation in brackets. Some of you forgot. If you write equal to without indicating your approximation, you know this is not equal to, exactly equal to this. This is rather approximately equal to. So if you approximate and you indicate, that we know that this is equal to this in 3SF. So please don't forget in the upcoming test. So that will be it for solution to question 3. Now let's go and look at that of what? 4. okay, which is somehow similar. Okay, so for the 4, this is what I did. Okay, so let's use using the terms in the expansion of this, find, okay, so with this one, nothing salient to underline. Okay, if possible, this will be extracted along the line. So definitely all that you have here will be extracted. So you won't underline. Okay, so given 4, your solution is what you write first, then question 4. Okay, your question number, given this what we are going to expand. So that will give us, here the power is 5, so you should be able to get the coefficient using the Pascal triangle. Okay, because the question specifically didn't say using the binomial expansion or the binomial theorem, you can use the Pascal triangle as advised. So the Pascal triangle, again, this is the power 5, so the coefficient will be 1, 5, 10, 10, 5, 1. So now what do we do? This will be equal to, the first term, the powers will decrease from 5 up to 0. The second term of the binomial will multiply and also give us power 0 up to 5. So you should know how I got this. Okay, at the normal circumstance, my first one, the substitution for the x and the y should be in brackets. But because I am showing maturity here, I ignore the brackets because it will not be costly. Okay, so if you had one of the terms or at least one of the terms to be negative, that's where the bracket critically, will be very critical. So at this point, you now go and, okay, deal with what you have here. So any number to the power 0 is 1, you don't write it. So this will give us, okay, y to the power 1, it is the same as y. Okay, this one, okay, will basically, this one, that will go in this one. So you know how to find your way out here. And this one, almost all of you, okay, if not all of you, did the right thing. Okay, so the next step, only that some of you use combination, which is allowed. So those of you who use combination, you are going to get n combination 0, n combination 1, n combination 2. And your n will be 5. So 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, 5 combination 5. So now, after you've expanded this, you are asked to find the summation of this. Okay, so what you have here, the summation of x plus y to the power 5 is what you have written out here. Okay, so you can see that you are summing all the terms here. So it means find, okay, x plus y to the power 5, its expanded value when x is equal to 1, okay, and y is equal to 0.5. So right there, therefore here there was no n. So the first part of the question, remember, okay, that wasn't what you were asked to. This is the direct question. This is what you were asked to find. But if you can find this, you will need the expansion of this. So that's the more reason why we expanded by the nature. So you can see that I didn't draw my conclusion for this one because I was not asked directly, okay, to find this or evaluate this. It's only a means to an end and to this end. Okay, so now, therefore, whatever that I am asked to find will be equal to, your x you've been told is what? 1. So wherever you see x, you substitute 1. Wherever you see y, you substitute 0.05. So that's what I did there. So again, in my substitution, just as I advised, okay, put your substitution in brackets and the powers will be outside the bracket. So your next step is to push the powers in, okay, which will give us, okay, that what we have here. The next step is to remove the bracket in each of the terms, which gives us what we have here. The next step is to, okay, add everything here, which gives us this. Here you were not asked to approximate, okay, so it means your final answer should be the exact value, not the approximated value. So those of you who approximated, please take note. I've told you, avoid approximation if possible, and here it's possible, okay, or unless otherwise stated. So here it's not otherwise stated that we should avoid. We should, yes, approximate. So now let's go. With this one too, you shouldn't get questions like this wrong. I've told you, you can use your calculator to check whether your answer here, because it's approximated value, you should take note. Okay, it's close to your, your calculator value. Otherwise, if it's the difference is huge, usually the difference shouldn't be that significant. If it's huge, then you have to go back and check. That's just by the way. With this one, to the same thing. If your difference is, you go back and check. Okay, so you are going to do 1 point, because it will be 1 plus 0.05. So that will give you 1.05 all to the power 5. Then you feed that with your calculator. Press equal to, your calculator gives you this. So here we are looking for the exact value. So your calculator should also give you the exact value because we have not approximated. Okay, so now to the question 5, which indirectly I walked you through. I gave you a way of dealing with it, in class. Now we are going to look at how actually we are supposed to deal with it. So this is somehow a different question because we've not handled a question that is stated in this form or is of this nature. So let's read the question, appreciate the question, then we move on. And let me go back, so quickly. I wanted to say something here, but I forgot. So in descending powers of x, why we underline this, descending powers of x, and here because you were asked to leave your answer in descending powers of x. Now let's see what is happening. You can see that we are asked to expand this in descending powers of x. So I want to say something here quickly. You have expanded, and you can see that in your expansion, you don't have what? Your expansion to be in descending powers of x. So if you conclude this way, you are wrong. So if you didn't think like I advised before writing, you will deal with it this way. But at this point, you don't end here. So this is what we are going to do. You are going to, so let me squeeze it here, which will now be equal to, then you, because here is the full arrangement, you didn't think before writing, what do? You arrange backwards. So that will give you 16x to the power 4, then plus 32x cubed, then plus what, 24x squared, then plus what, 8x, then plus what, 1. So if you end here, you won't get the score, the final answer score. Take note. So those of you who thought before writing, you first of all write this to be equal. Remember the advice, because you know that the first term, if your x is in the first term of your binomial, the powers will be in descending order. It means your first term must rather take your x term. Your second term, the powers will rather be in ascending. So in this case, you would rather write this as 2x plus 1 to the power 4 before you do your normal expansion. In that case, when you are quoting the formula, you don't quote the special one because your first term is not 1. You have to quote the one with a plus b, to the power n. Take note of that. I guess my point is well made. So at this point, it means here, because you were asked to, use your previous result, which is the hence situation. It means when you are substituting, it should be backwards, but you end up getting the same answer. So at this point, if you use this, please take notes. If you use this, you'll be marked down because you were asked to get your expansion in this form and use this form. So take notes. So all that you have here will be gone in terms of marks. So take note of that. All right, so that's what some of you did. I did it this way so that, I will have your attention drawn to that. Next time, you will do the needful. So quickly back to where I was. I almost forgot. Thank God I remembered. So now what do we have? We have this. So we said when 1 plus ax all to the power 10 is expanded in ascending powers of x. So, the order of our expansion in terms of the powers of x, very critical. Then the series expansion is a plus bs plus cs squared plus 15s cubed plus ellipses. Find the values of a, small a, capital B, and capital C. So an interesting question. You can see that in the expansion here, so you are trying to say that if you expand this, and get the first four terms, this is what you are supposed to get. So what do? We take this, expand, up to the first four terms, which will be the term in s cubed. That's where you are supposed to end because of where, the series expansion is given, or the given series expansion ends. So now what do we have? Solution. Given. We come and the first term is 1, so we thank God. Expect the first special one. Go and put the special one, which is the 1 plus s to the power n is equal to, in terms of the combination, you can use combination because of the power, being a positive integer. So 1 plus n combination 1x, n combination 2s squared plus n combination 3s cubed. Like here, your x is what? Ax. Your n is what? 10. So it's 1 plus 10 combination 1, x, which is now as to the power 1. Okay, then plus 10 combination 2. You can choose not to write the power 1, you know. Plus 10 combination 2, your x squared. Your s is now ax. Okay, you put that in bracket square. 10 combination 3, as cubed plus your ellipsis. Okay, so we ended here. I've explained why already. So now you come and deal with the combination value. 10 combination 1 is what? 10. Okay, then push the powers in. So that will give you ax. Okay, then 10 combination 2 will give us 45. So this will give you as squared, s squared. Then 10 combination 3, if you push the power in, you get a cube s cube. So that gives us the plus ellipsis, what we have here. But we are told that this first 4 terms of the expansion here must be equivalent to what we have here. So take note of now, identical to what we have here. So, but we know that the expansion here should be equal to or identical to the expansion here. So now what do we do? You come and compare coefficients. So if you compare coefficients, obviously you say that the constant term here, 1, a must be equal to 1. So a is equal to 1. Okay, that will be, so get all of them, then you label all. Once you get this, a is equal to, I label this as equation 1. Okay, I have how many unknowns to find? 1, 2, 3, 4. So it means at least, okay, I need to generate 4 equations before I can solve them simultaneously to get all the 4 unknowns. So a is equal to 1, my first equation. My second equation will come from comparing the coefficients of x. So the coefficient of x here is what? 10a. That of the x here is b. So 10a must be equal to b. Okay, the coefficient of s squared here is 45a squared. That must be equal to coefficient of s squared here. So 45a squared must be equal to c. Okay, then with this one, I label it. Okay, equation before you label, check if you can simplify. Okay, check if you can clear fractions. Remove all brackets to before you label. So in this case, I can label it no fraction, no brackets, I can reduce. No fraction, no bracket, I can reduce. Then I come here and do here, what do I have? Okay, I have my coefficient of s cubed, 120. A cubed must be equal to coefficient of s cubed here, which is 15. But obviously you can see that here you can simplify. You can solve for your a because here this is only in terms of the small a. So what do? Write it again, divide by 120. You get a cubed is equal to 1 over 8. This simplifies into that. You can find the a. So you can see that I didn't label it here because I realized that I can simplify. So like I advise, remove all brackets before all brackets, all fractions, reduce your before you label. Okay, if possible. So here it's possible, take the square root of that cube root. Okay, so here it should have been cube root. Forgive me. So it wasn't. So let me write the cube root here. I will do the editing in the PDF version of the data I will send. So let me clear this and write it well. So this will be cube root rather, not the square root. So cube root will be here. All right. Okay, so that gives us what? A will be equal to what? Cube root of, you use a calculator. A calculator will give you one of the two. So at this point, you can label this as your equation 4. Now it means you know the actual values of your capital A and your small a. So you are left with what? Capital B and capital C. Now because capital B depends on A, if you want to find B, you have to substitute the small a value into what? The equation 2. So your small a value is what you have. Because you put this one into one equation, another equation, label it so that you go and write, okay, your equation 4 into equation 2. And please take note, those of you who wrote this, okay, don't write puts, don't write substitutes. It's not necessary. Okay, if you want to write put and you want to write substitute, write, okay, the continuous form. So you write putting, substituting. If you write put and substitute, it's like you are commanding the person who is marking or who is going through your work, which you cannot. Okay, so you are walking us through so you're supposed to be putting, substituting, but it's not necessary for you to write that. Just come and write your equation number that you are substituting. So you write equation 4 into equation what? 2. And those of you who labeled your equation as this way, equation 1. Okay, it's not necessary to write this. It's not universally accepted. So just do your dot, 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 then you come and label your equation. Just write 1, okay, 2, 3. Don't write the equation. It's still simply understood to be there. So once you have this in bracket, when you are reading it, you read this as equation 4, equation 1, equation 2, equation 3. Take notes. All right, I guess my point is, so it will be equation 4 into, so you can see how I'm reading equation 4 into equation 2. That's what you are doing. So you are putting that into that. So comma. So this will always be too short to take a line. So you shouldn't come down. Continue. So if you substitute, you get your B to be equal to 10. I decided to write the B first. It's equal to 10 into your A, which is half. So 2 will go here and you get B to be equal to A. This one, okay, it's a grave error. I think I have to go back and, okay, do the correction as soon as possible. Okay, so sorry, I've done the change. Okay, it's supposed to be 10 over 2, which will give you 5. I wrote 2 there. So that was a grave error. Okay, so now if you want to find your C also depends on A. So it means if the A value is wrong, your small a value is wrong, automatically B will be wrong and C will be wrong because the two depend on what? On the A. So in that case, you are going to get C to be equal to 45 into half what squared, which is your A. Okay, you know, if you are substitute, you put it in bracket. So that will give us 45 into push the power in, and that will give you 1 over 4. Okay, then now you are going to get C to be equal to 45 over 4. Okay, so at this point, you know the values of all the letters that you were asked to find, or the unknowns. So you write therefore, and if you can conclude with your values also in that order, is better. Somebody could have concluded this way, therefore A is equal to 1. Okay, therefore, after getting this, write therefore here, write therefore here, then come and write therefore. Only that way, this one, the C cannot conclude with this value. Okay, you must change, you know, avoid concluding with an improper fraction unless otherwise stated. So you must change to what its corresponding mixed numbers. Okay, so I know that I didn't change it here, but I would change that in my conclusion. So that's what I did. So therefore, A is equal to 1 over 2. That's small a. Capital A is equal to 1. Okay, capital B is equal to 5. And capital C is equal to the mixed number version of this. So that will give us 11 whole number 1 over what? Over, okay, 4. So, okay, on this note, this becomes the solution to the first part of what? The team assignment. That is question 1 up to what? Question 5. Okay, so in our next meeting or our next class, okay, the next session we'll be looking at solution to the second batch of the question, which will be 6 up to what? The second half, 6 up to what? Up to 10. Okay, so on this note, thank you very much. If you have any issues, okay, please don't forget to comment, okay, and don't forget to like, okay, share the video whenever you get access to it. Okay, thank you very much. God bless us all.